runs, then if this runs, then we should be fine. Okay, this. Okay, so all I did was I just did check for one of the 6 links. So for example, I chose 3 just randomly. So MuJoCo gave me body frame velocity linang of this. This is from my calculation. Sorry, my calculation is above here. So you can see these values here match exactly with these values which MuJoCo computed. Right? And then you can see the same thing for the COM. So the ones on top matches with the ones below, and the tip velocity matches. So I just did exactly what I did for the planar manipulator. I just verified one manipulator. How is this possible? How did I do this? Well, if you go through, when I post the video, when you go through the video, you'll see you can do exactly what I did step by step, but you have to repeat it for this manipulator. So first thing I did was I defined a qvel, just some random numbers because I wanted to do the check. I went in MuJoCo. And then by the way, this file was started from the forward kinematics file, which I wrote down earlier. So it was not from scratch. So you could take the forward kinematics file from previous lectures, take it over here, and then I accessed the velocity in a variable u. And then I put it in data.qvel. When I do this MJ forward, actually propagates puts the velocities and position inside MuJoCo, and then basically does the computation of the forward kinematics. So then I have differential kinematics. This is the main thing which basically does the calculations which I put down there. There is the solution, and there's a robot which I think I kind of need it because I'm storing values in robot instead of the solution. So this basically prints everything which you saw there. Now let's look at the inner working of differential kinematics. So here what I did was, instead of trying to do it, write equations for different links. Remember, I had 3 equations for the 3 links, and I had to propagate them. I just made a for loop, and that way I can just make it do it for any number of links. I don't have to really do the calculations again. I also have access to this file called robot_body, which basically had all the details of the kinematics. So that is actually called in forward kinematics. So the forward kinematics accesses robot data. It basically calls, takes in the position, the quaternions, and so on from the robot data file. It basically computes the H local, R local, that's the local homogeneous matrix. Then it computes the global homogeneous matrix. And then I only send in the end effector position. So once I do this work, I can now use differential kinematics to the rest of the work. Here I basically getting the axis, the positional center of mass, the position of the frame in local coordinates, the rotation matrix, and then the R global, which is a work which I've already done in the forward kinematics. This part of the file does that forward propagation. For the first link, it's a special link because the velocity of the world frame is 0, and I don't really have a body for the world frame. So I need to use this particular thing for only the first body. But once I have the first body figured out, then it's just recursively using those equations. I compute the local velocities. So this will be, for example, W11, W22, and so on. This will be the velocity of the center of mass in local frame. And then to get the global velocity, I just have to multiply with the global rotation matrix, which is, for example, R01, R02, and so on, and the velocity of the global frame. And then I do the same for the tip velocity, which is the 6th link. Okay, then I just send this back, and then all that MuJoCo does is, this file does is just prints it out. To get the same values from MuJoCo, I go to UR5.xml. I define a sensor tag. And you can see that there are 5 things defined, just like previous. We have the center of mass velocity for the 3rd link, which happens to be 4-arm link. We have the linear and angular velocity of the frame. and then the tip velocity. So all those things, once defined, can be accessed from MuJoCo using a data.sensor. So it basically takes the value I computed from differential kinematics, takes the data from MuJoCo, puts them against each other, and you can see that they match, which means that calculations I did sort of agree. Okay, so I'll give you this file, and then for your homework, it's basically, which now you can do, you're doing the same thing for the WX, the Prosan Widow X robot. Okay, essentially the same thing, exactly the same thing. The UR5 should help you to do it. And you can just follow my video to see how to put the steps together.